Hi friends, welcome back. I hope after the two consecutive parts in the journey, now you people have taken enough rest and you are fresh to start with the relations. And let's begin with the part quickly because everything will be self-explanatory about the part, and we'll meet after the video once again. Although I'll be there within the video also, but we'll meet like this at the end of the video again. Starting with the relations, so I hope that all of you must have revised till now all the sets part, all the properties which we have done, and now we will be applying one more property we will be learning from which we will be basically doing the relations part. Okay, now let us start with the introduction, and then you'll get to know that how the sets are being applied in the relations. So first thing which we have done difference of sets, addition of sets, union and all. Okay, one more operation which I did not touch because this will be basically applied here, how to multiply the two sets. The multiplication of two sets is basically known as Cartesian product. So let us basically look that what Cartesian product is. So Cartesian product of two sets denoted by, now this is how we represent, like you remember the set was represented by this one. So this is how or the union, intersection, subtraction, difference of sets, okay, symmetric difference if you remember, yes. So this is denoted by A cross B, the word order. Okay, now I'll talk about the order later on. Let's first figure it out. Is the set of all ordered pairs xy such that x belongs to A and y belongs to B. Now what does this mean? Okay, now we are saying that there's a set, suppose A, and there's a set B. Okay, the product of two sets is defined as a pair, ordered pair. Now again, ordered pair I'll explain, xy such that one element you take from here, the other one you take from here. So all the possible combinations, like suppose here it is 1, 2, 3, A and B. So I write A cross B as, so I have element 1 from here. Okay, so with 1 I can match A, with 1 I can also match B, with 2 similarly I'll do, and remember these all are different elements. Now again, the best way to understand Cartesian product is like on the number line. We used to represent the numbers in one dimension. When we learnt about the Cartesian plane, we studied that how the two numbers, they can be represented in two dimensions. The same way we can represent two sets using Cartesian products, and it will be the pair, like one will be from the first, and the order matters. Okay, now if I do it the other way around, so it violates the definition that A is belonging to set A. So for this one I have to write B cross A. Okay, now again it says if A contains m elements and B contain n elements, then the Cartesian product will have m into n. Now why this? As we have observed for the first case, like 1 is related to two things, 2 was again for 2, and 3 was again coming to the two objects. Okay, so m into n, like here it was having 3, here it was having 2, so 3 into 2. So 4 I have listed, similarly 3a and 3b. Okay, now again we can also define Cartesian product, like as we can define dimensions for the third one also. So but in Cartesian product we don't have that limitation, we can go as much. So it will be just like if there are 3 elements, 3, or even if I read 4, so it will be ordered pair of, not pair, but it will be a combination of 4 things, x1, x2, x3, x4. Now this will belong to A, this will belong to B, so there will be a lot of combinations. So it will be you just multiply the number of elements and you will get the, okay. So moving on to the next one now, relation. Now coming to the part relation. Okay, just hold on for a second. Yeah. Now this says that A and B be two non-empty sets. Again, first of all, like when we are defining relation, okay, the first thing which should come to all of you is that when you're relating, you're basically associating two things. So if one is empty, then you cannot associate with the other one. So both has to be non-empty sets, and every subset of this defines a relation from A to B. A perfect example of this will be, consider yourself, okay. Now you in a family is related to your mother as son, to your sister as brother, to your brother as brother, or if you are a male child, obviously, if you are a female child, then you will be related to your mother as daughter, and to your siblings as sister, and to your grandparents as granddaughter or grandson. So one person, if I change the definition, the relation becomes different. You know what I am trying to say? Like if I consider your family, okay, where if I consider you as one part, family is a set, okay. Now again I am taking your family itself, the other set also, that we can, we'll define it later on, that set can be related to itself also. So you, suppose mother, and suppose grandfather is there. Same way we will write here the same things. Now if I define the Cartesian product, it will be you will be paired up with you, okay. Now you will be paired up with mother, you will be paired up with grandfather, and similarly for mother with you, mother with mother, mother with grandfather, okay. Now it should be very clear that if you are, this is the maximum possible relations. Like relations, what do I mean by relation? When you are relating one object to the other object using a rule. Now if we don't say a rule, then we say it's a Cartesian product. But if I say that, if I define a rule, then it become a relation. Now suppose I say that, like we defined A cross B as A comma B, A was belonging to A and B was belonging to B. Now if I add a condition like A and B should be brother, B should be the brother of A and B, they should be related as father and son. Now again, if I add this line, then this becomes a relation. So the only difference is that in Cartesian product, everything is related to everything. You don't have any boundation. Again, that is also relation. Okay, depends on the definition. Like suppose if I take a case of 1, 2, 3, 4, 5, 6. I say that A comma B should be A cross B. Give me a relation from A to B such that A comma B should be the part of that relation and A and B should be the natural number. Now you see that in this case the relation will basically form the Cartesian product. How? You can relate each element of A to each element of B. Okay. So this is written like this, that this is a subset. It can be the Cartesian product itself, but it's a subset. Okay. A is related to B by relation R. Now this R is basically the condition which I was talking about. The relation which you will be writing it as A related to B, okay, and this is A is not related to A comma B not belonging to R, okay. Okay. So that was from the theoretical part. I hope that you are able to get that now. What we have basically done, that initially we were playing with the sets, we were looking at the set representation of set. Now we have connected two sets. So the basic way to connect two sets, like each element of set to the other one, was Cartesian product, where we multiplied each element, or basically multiplying here means like writing in an ordered pair. So ordered pair, now I mentioned the word ordered pair. The ordered pair basically means that if I am saying 3, 4, 3, 5. So basically if I am writing this is a Cartesian product, this means the original sets will be 3, 4, 5 like this. Okay. Now if I write 4, 3 and 5, 3, it's the different one. The first set becomes 4, 5, 4 and 3. Now again the difference, it will be like, you can say, if I say A comma B and I am saying B is the father of A, so you cannot write BA, right? If If you cannot be father of your father, right? So if you have a father, if I am saying B is the father, so you will write father here, your name here. You cannot write, okay, like this. In this case, the relation will change. The relation here will be A is the son of, or it's just a definition like, if I am saying this one, so I have to mention that A is the father of B. That's how I can write it. Basically, the position matters where you are, writing the same thing. Let us look at here. Now, if A is given to be this, now A cross B. Now, A cross B will have 1, 3, 1, 4, 2, 3, 2, 4. All of you must be able to write the Cartesian product, okay? B cross C. B cross C again, 3, 4, 3, 5, 3, 6, 4, 4, 4, 5, 4, 6. Now, intersection here, if we look at the intersection part, it's again, see, earlier we were finding the intersection with one element. Now it's ordered pair. So if the ordered pair, both the elements are same, then we can say it's same. So I'll write basically both the things so that it's clear to all of you. It will be A cross B will be 1, 3, 2, 3. So I'll write, symmetrically so that it is very clear to all of you. 3, 3 and 3, 4. Now these again are all elements, but two-dimensional elements. Like earlier we used to write A as 1, 2, 3. So this was also a set. Now if you are writing it within braces, it means it's two-dimensional things. Basically, one is coming from one set, other is coming from, this is also a set. Okay. So this is A cross B. Now B cross, C will be again 3, 4. Now since we have to find intersection, obviously we don't have 5, 6, so we don't require this column basically. So 4, 4. Again, remember these are to be separated by the commas because these are different elements. 4, 6. Similarly 5, no 5 is there, so only this thing. Yeah. Now we have to find intersection. Intersection means those who are common, right? So now if we have a closer look, so we will find that this is the only element which is common. Now note here that the opposite one won't be taken off. Like if there would have been suppose an element 3, 5 here, 5, 3 here in this one. Okay, so this would not have same as maybe an element in this one. Okay, ordered pair means it has to be both the first elements and the second elements, they are same. Like you used to do in the coordinate geometry, if both the coordinates are same, x and y has to be same. Same way if you are comparing two ordered paired set, elements of set, so both the elements should match. Okay, moving on to the next question. Now this is a favorite question of in JEE mains, you can see. Similar question, like if I mix this question with permutation one which we might be doing in the previous year, JEE questions, or it might be there in the test paper solutions. So more advanced level of them. Right now we'll be sticking to the basic. Now it says that R is a relation from finite set A having m elements to a finite set B having n elements. Then the number of relations from A to B is. Now what we have done, that A is having m elements, B is having n elements. Now we know that the relation is a subset of cross products. So cross product is having how many elements? M into n elements. Now the number of relations. Now since this is having m and elements, we started, if you remember, that for a set having n elements there are 2 raised to power n relations. So basically this will be straightforward, 2 raised to power mn. Let us figure out with an example so that it becomes more clear. It will be basically A if I take 1, 2 and B if I take 2, 5, 6, any So for this it will be A cross B as 1, 2, then 1, 5, then 1, 6 and 2 comma 2, 2 comma 5, 2 comma 6. Now what do I mean by relation? Now this is a Cartesian product, Now if I say that let us form a relation, from A to B, such that A comma B, if I say that such that R is equal to A comma B, A belongs to A and B belongs to B, A is equal to B plus 3. Now this becomes a relation. I am relating A and B by a rule, okay. So this rule becomes a relation. Now if we figure out in this one, A is B plus 3. So let us figure out that now in this case, all the elements are, in all the elements B is greater except this one. So this relation will be a null set. Although we are applying this relation on these two sets, but there is no element which satisfies this one. Now what if I change the relation? If I write it like this, B is equal to A plus 3. Now we can figure out that this relation, this element will be satisfying this relation. So depending on this definition, depending on the definition, your relation will change, and such number of relations. Now either relation can have one element. Now if I would have said A plus 1, so then this would have been the choice, right? So this has to be clear that depending on the definition, you will have different sets of relation. The different relation possible will be subset. Like if I am taking this one, this is a subset of A cross B. If I am only taking this one, again different subset of this cross product. So this should be very, very clear now, like what the relation means. When we are writing this statement, writing a condition, okay, to relate the two sets. Basically, if I am saying that the relation is father, okay, and you are standing at one position, your mother. So obviously you two won't be related if I am asking this. If I am asking that, okay, I want a set of mother and son or mother or daughter, then you will move forward and come to me. So this is how we define relation, and in mathematics we will be relating the numbers. I hope that you are clear with the property which we have not done on sets, that is the multiplication of set, another operation, and from that Cartesian product you people are clear about what the relations are. As you associate yourself with your parents, your family members, or to a friend going on a road, okay. Similarly, numbers, they can be connected by some special relation or rule, basically, that we termed as relation. So in the coming parts, we are going to study more about types of relation, the JEE questions and all. So do this, understand this part comfortably, and stay tuned for the coming parts.